Hello, welcome to assembly call. Today we are going to solve the day 30 of July LeetCode challenge. So today's problem is word break 2, right? So if you read the problem statement, it's saying that you will be given two input. One is the one input string, another one will be a dictionary or list of string, right? Then you need to find the output, right? So you need to find that number of sentence you can from using that dictionary and in the using that input string, and you need to return that. So there are one condition is here that your sentence length should be equal to the actual input string length, right, excluding the spaces, right? So if you exclude these two spaces, it's also 10 word 10 character, it's also 10 character, right? So you need to find all the possible combination and you need to return the output as a list of string, right? So let's go through this problem further. Let's do some deep dive. So you can see that how we can solve. So suppose you are thinking for the first time how we can solve it, just what is your top of the mind right now. So you can think that I can pick any word. So probably I can start with cat, right? And I will check this word is exist in my string or not. If it is exist, then I will only consider this portion of string, right? Again, for this portion of string, I will check that is there any more word. Yeah, I can find, okay, sand is also exist, right? So I found two word, cat and sand, and I'm going to append that. Then again, my remaining string is dog. Again, I can found the dog word is also exist in our dictionary, right? So I can form one string like this, cat, sand, and dog. Another possible combination is I can start with cats, right? This is my first word. Again, I will check and is also there, right? So I will just consider this portion dog, right? And again, dog is exist, so I can return output like this only, right? So let's solve it. Let's try to solve it. So let's decide how we can solve, right? So let's decide the approach first. Then we are going to write the code. Okay. So this is my input string, right? So how we can solve it in normal scenario? Let's think that only. Okay. Okay, so how we can solve it? So we need to at first find the breaking point, right? How we can find the breaking point? So again, what I can check, I can pick any word and I can find from where it starts matching, right? So in this case we have two breaking point, right? Two possible condition. One is cat and another one cats, right? Since we need to maintain the same length, right? So we can't start with and, right? If I start with and, then we can go to backward, right? So obviously my string should be start either with cat or cats. We need to find the breaking point first. So probably at first I found the word cat, right? So if I found my word cat and I subtract that word from my actual word, so then my remaining string will look like this, right? So how my remaining string will look? So it will look like this. So it will be like this, right? Then again I will try to find that is there any other word that exists, and I found. So what is my next word? So if it's sand, right? So I can found, okay, sand is also exist in my string, right? Then again my word left is only dog, right? Then again I will try to find is there anything else, and I can found, okay, I can found that dog is also exist, right? So I am going to add dog here. After that it's null, right? Similarly, once we are done with this portion of the tree, I will go back and check anything else. So this is no more option, right? Then I will go back. Anything else? Then again there is no option, right? Then again I will come back here and check, okay, I have another option, cats. I can start with cats, right? And if I start with cats, then my remaining string will look like this, right? So this will be my remaining string, like okay. And then again I can check, right? Again I found that, okay, I can subtract and from here, since and is already exist in my word dictionary, right? So and then I can, so my remaining word is dog, right? And again I can just use the dog. So since the dog is already exist, so I can subtract the dog also from here, and my remaining will be null only. Okay, so again I can subtract dog. I think that's pretty much. So this is the kind of recursivity. So we can find that this is a small example, but if you draw in the same way the recursivity for the big example, you can see there can be some sub problem like this portion, right? That we already solved it, right, in this scenario. So we can reuse those sub problem, right? So since it's a small tree, but your input or word dictionary is large, in that case your tree will be much bigger, and you will find that more common sub problem, right, that we already solved. We don't need to reiterate or resolve those, right? So let's try to solve this. So how we can solve this, right? So this will be our approach, right? So I will start from my actual string, then I will find some breakpoint, and if I found my breakpoint, then I will keep checking my rest of the string, and again I will still go till my size is met, right? The actual sentence size is 10, right? And if we found my 10 size, then I will go back again and I will check that any other combination exists or not. So basically you are going to use two approach. One is the depth first. Depth first means we are going to the depth of the tree till we find the null or endpoint, and whenever we will reach our null endpoint, we are going to backtrack, right? So from here I am going to come back here, then again I will check for the other combination, right? So let's write the code in Java. So let's try to write the code, then I will again explain in details. So what I will do, at first I need to take one, we need to return list, right? So I will take one list, probably it will be result that we are going to return, and it should be an array list. After that, what I need to take, so I am going to create one DFS function. I am going to define that after a few minutes, and at the end we are going to result that we are going to return the result, right? So for this DFS function, what we need to pass, we need to obviously pass our dictionary, right? What dict, again we need to pass our actual string, again we need, since we need to form the sentences, right? So for that we are going to take the string builder. So since the string is immutable, so probably we are going to take the string builder in for better uses. And after that I need one index also. So index will be used to keep tracking the index, right? From where should we start, right? Whenever we will find our first word. Okay, so there should be an index, and index should be initially 0, and again I need to pass what I need to pass. So there are some edge case scenario when your word is not breakable, right? So there is one test cases for that. So to handle those kind of scenario, I need to maintain one boolean array. So let me declare that also. It should be new boolean, and its size should be s.length plus 1. Okay, what else we need? So we also need the actual result array, right? Else we will not be able to add in that array. Okay, so now let's define our actual BFS function or implement it. So its return type should be void, and let me name it as DFS only. Again, what we are passing here, we are passing at first the word dictionary. Let me copy that also. So we are going to pass word dictionary, then we are going to pass our actual string is s. Again we are going to pass one string builder, and after that what we need, so it should be sb, something like this, and we are passing our index also, that is, let me define as index only. After that we are passing one boolean array to handle some edge cases. So basically we are going to check that a string is breakable or not using that boolean array. So probably let me name it that invalid, something like this. Now what I need to again pass my result, right? So that should be list of string. Okay, so yeah, something like this. So okay, let's implement it. How we can implement it? So at first we need to check my if my index equals to my string length. Okay, so if it is matched, so you will get better understanding. Let me finish it fast, and I will obviously discuss each and every step. So what I do, we will add it in our result, right? That means whenever I will find my one sentence with similar length, I am going to add it in our result, right? So it should be result.add, and since we are using string builder, it should be sb.toString. Okay, now what I need to do, and once we found our one sentence, I am going to stop executing, right? So since it's void, and I can directly write return. Now what I need to do, now we need to write our actual logic. Okay, so I will start from, so initially my index will be 0, so obviously I will start from my next position. It should be index plus 1, and again I should be less than equals to s.length, since we are considering the substring, so that we are going to still less than equals to length, right? Then again I am going to do I plus plus. Now what I need to do now, so there are some edge cases. I will discuss that in future, after some time, after completing the code. So there are some edge cases, so we need, so that we take this array. So I will check that invalid I is false. Once it is false, then only we will, so if the code is breakable, then only we are going to perform the logic, right? Else we are not going to perform, else it will throw the time limit exception, right? Time limit exception. So after that what I need to check, so I am here right now, this is my word, right? So I need to check that anything. So I'm taking one loop, right? So I will start from only C, and again I will check that okay, C is not present, right? There is no word called C in our dictionary. So I will increase my counter, right? I will check for CA. Again I will say okay, CA is also not exist, right? Then again I will increase my counter. Then I will find cat. Okay, cat is there, right? So cat is present in the dictionary. So I am going to check that first, right? So how we can check? So it should be if and word dict. So I will check the dictionary contents. So our list is contents this word or not, right? So how we can identify the word? So I can use the string substring method, and I can pass two things. Index will be our starting point 0 and my I value, right? It should be 0 and 2, right? So that will give me the cat word, right? If it is exist, then I need to keep two things saved. One will be the old size. What is the old size? It should be the result.size. So this is again to check the string is breakable or not, and again I need to store the length also, probably old length, right? So it should be it should be sb.length. okay, so you will understand why we are taking these two. So OL, after that I will check OL not equals to 0. Then I am going to directly sb.append space, right? So what we are doing, suppose I found this first word, right? I need to add it in our sentence, right? So if it is the first word of that sentence, then we don't need to append 0, right? So that we are doing this or tracking this, okay? Else we are going to directly append the word s.substring, and it should be index comma I. So this is my cat, right? I am going to insert that or append that in our substring. Now what I need to do? So now I need to perform BFS, right? DFS to find find the combination for rest of the words, right? Rest of the string, okay? So what we need to pass? We need to pass our word trick, that will remain same. I need to pass my actual string, that will also remain same. I need to pass my string builder, I will going to pass same string builder. And okay, so in this case, since I already covered this portion, I am going to pass from this, right? So I am going to pass the correct index, right? So next index only. So it should be I instead of 0, it should be I, right? And after that again I am going to pass the same invalid array, boolean array, okay? And I am going to pass my result array, okay? So now once we are done with DFS, whenever I found my whole sentence, what I need to do? I need to check that this word is still breakable or not. So how we can check that? It should be invalid. So this is for handling some edge cases. So if it is so it should be old size. If old size equals to result of size, actual size, then that means the word is not breakable. Then we are going to just set it true only, okay? So that means that's the invalid string, okay? So it should be true, so that we will not iterate further to avoid time limit exception. This is for only one scenario, okay? Now what I need to do? So let's just forget this portion. Now we are done with DFS, right? So I found the whole word, right? Now what I will do? I will backtrack, right? So I am here right now. I need to go back and check that is there any other combination. Not for this example, but for some other example, we can have other combination with dog, right? So we can have some word called OG, right? Or do, something like that. So we need to handle those kind of scenarios also, right? So how we can do that? So we need to just sb.delete. So we need to, what I will do, this is my sentence, right? So I will delete this last word, right? I am going to delete it, so that then I can check for other portion, right? So I'm going to do that only. So it should be my old size or old length, and it should be sb.length. Okay, so using this we can delete the last word, okay? I think that's enough. Let's run it and check. After that I am going to explain it. Yeah, it is giving me expected answer. Let's submit it also and check, right? Okay, I think it's accepted. Now let us discuss the code one by one, line by line, so you will have much better understanding. Okay, so let me copy the code, and this is my code. Okay, so what we are doing here, at first I will told you. So I will start, this is my sentence, right? I am starting from index plus 1. So this will be my first word, right? I will check that CA is exit on my dictionary or not. I will say it's not exist, right? I will move forward. I will increase my counter. I will found this word cat is exist, right? Okay, so it's exist, right? So let's forget this portion also. So it's exist. This is true, right? So I am going to store the size and I am going to store the length. Initially it will be 0, and it is also 0. Okay. Now if it is not a fast word, then I am going to add space, or else I can directly add the string, right? So I will add like this. It should be cat. Cat is already there, right? Now let me increase the size probably. Yeah, so it should be cat. Okay. So it should be cat. I found my first word. Now what I do, I again call the DFS. In this case, I will start from this location, right? So this is my substring. I will start from this location. Again, I will check, is there anything else? Okay, I will find, okay, sand is exist, right? So I am going to add that, append that. So it should be, so I'm going to add one space, then I'm going to append that, right? So my array will look like sand. Okay. Now again, I will go for that for dog. Okay. I will for dog, I can see this all word also exists, right? I'm going to append one space and I'm going to append my actual word dog, right? Now once we are done with that, and we will find that okay, this condition is matching, right? The first condition. So my index will be here. So my index will be here, right? So that is the equals to string length. That means we are done. We found all the possible words with similar length, right? So we found this word. So we are done. So our execution will stop fast, right? Then I will go move back. So since it was recursion, so I will come back here and check. So this is for specific cases, forgot that. So I will execute this line, right? So in this line, what I will do, I will delete that particular word, right? So I will delete the dog word first from my sentence. I will delete it. Now I already stored the first string, right? So now I delete it. I will come back here and I will check, is there any possible other combination? No, right? So again, I will delete the cat also. Then I will be here, right? Again, I will check, is there anything else I can check from the cat? No, right? So again, I will start from cats, right? So again, I will start from cats. Again, I will find another word called and. Again, after that, I can found dog, right? So like this we can do, right? So we are doing that only, right? So this is how I tried to solve the problem. Let's check the time complexity also, and let's see how it performs. Probably we can improve it also. Yeah, so it's saying that it's not overall good. So how we can improve that, right? So there are multiple ways to improve that. You can try it yourself, or if you still have doubt, I can help you you can let me know in the comment section. I can help you. So basically, what we can do, so we can use one maximum variable, right? So I'm just giving you hints. So you can use the max. So what we can do. So we don't need to run again and again, right? So we can store. We don't need to run this for loop once again and again, right? So we can put extra condition. I should be always the less than index plus max, right? So you can use that kind of condition so that our runtime will decrease drastically, right, for larger input. Okay, so we can do that and to increase our performance, right? So how we can what we can do, we can iterate through this dictionary and we can identify our maximum word size, and then we can just in this for loop condition, we can add one condition that I should be less than index plus max, right? So we can do something like that so that we will not need to go through all the for loops, right? So all the possible combination. So using that, you can improve the time complexity for sure. Okay. And okay, so let me discuss the last portion also for why we are taking that extra array, right? So this array, right? So this condition, let me comment it out and check what is happening. Okay, you will get better understanding after seeing this. Okay, so I remove that condition right now. Okay, let's run it. So you will say it will run properly. Yeah, you can see that it's giving me expected answer, but whenever you submit it, so there is some edge cases or condition, some test cases with very large string. Okay, so you can see this is a very large string, and so this string is basically not breakable, right? So you can't break it. To handle this kind of scenario, we are checking this, that is the string is breakable or not, right? So that's the reason. So if you like this video, please subscribe to our channel, and thanks for watching. Bye bye.